Imagine trying to coordinate a massive fleet of semi-trucks. Half are hauling incredibly heavy, pristine 4K video, and the other half are carrying perfectly synced audio.
Right, and they all have to drive across the country and arrive at the exact same millisecond.
Exactly. But if you force them down, a tiny, winding dirt road, you just get a catastrophic traffic jam.
Yeah, the video stutters, the sound drops out, the whole thing just falls apart.
Yeah.
That dirt road is basically what happens when you try to force raw, Ultra HD video down standard copper wires over long distances.
It just doesn't work. To fix it, you really have to ditch the copper entirely and build a superhighway made of light. So, welcome to today's deep dive. Our mission for you today is to cut through all the dense AV engineering jargon.
Right, we're looking at a piece of hardware called the AJA 12G-AMA-TR fiber transceiver to really uncover how massive amounts of data actually travel flawlessly in the real world.
Because the core challenge here is distance, right?
Exactly. It takes these heavy digital video feeds and literally shoots them across a network on laser beams through fiber optic cables.
Okay, let's unpack this. Because this specific box handles something called 12G-SDI architecture, which for anyone not building broadcast studios every day means it's processing up to 12 gigabits of raw data per second.
Yeah, it is an ultra-fast on-ramp, and it routes all that data using LC fiber connections.
Those are the tiny click-in fiber plugs, right? The ones that lock securely into place.
Yeah, which is absolutely crucial when you're bouncing massive amounts of data over delicate glass threads. But what's fascinating here is the sheer efficiency of that light-based highway.
Oh, you mean the latency specs?
Right. The video latency on this unit is just 3.2 microseconds. I mean, because we're transmitting via light, that data transfer is practically instantaneous.
That is wild. It's why fiber optic infrastructure has become the absolute gold standard for live broadcasting. But, dealing with the video is really only half the battle. You still have to handle the audio.
You do, yeah. And this device functions as an audio embedder and disembedder.
Right, which basically means taking a standard analog sound waves, digitizing it, and then precisely interleaving it into the blank spaces of the video data stream, so they travel as one single package.
Precisely. And if we connect this to the bigger picture, think about a massive sports bar network managing dozens of screens.
Oh, sure, yeah.
The disembedding feature allows audio engineers to do the exact reverse. They can surgically extract that audio out of the digital video feed and route it to a massive house speaker system.
Right, and it actually comes with an XLR breakout cable for that, giving you 4 channels of standard 3-pin analog audio going in and 4 coming out.
Exactly. So you could pull the game audio out to the house speakers or even inject a local announcer's microphone directly into the digital video feed.
Here's where it gets really interesting, though, because I have to push back a bit. Pulling specific audio channels out of a live, interleaved digital light beam sounds, frankly, incredibly delicate.
It does sound complicated, for sure.
Right. Like, if I'm running a sports bar or a live venue, I don't have an IT team on standby. How prone to failure is a setup like this? Because it sounds like you'd need an engineering degree just to turn it on.
It's a totally fair concern, but the design actually removes most of that human error. It automatically detects and configures the input video standard the second you plug it in.
Wait, really? So you don't have to program the synchronization from scratch?
No, not at all. You can just plug into a laptop via USB and use their mini config software to route things, or even use the DIP switches.
Ah, those tiny physical toggle switches on the side of the box. So you can manually lock in your settings without a computer at all.
Exactly. It is surprisingly elegant.
Yeah.
At $1,835, it's a serious professional-grade investment.
Yeah, that's not cheap.
No, but you're paying for absolute reliability. It's backed by a 5-year warranty, all packed into a tiny, rugged box that is only 5.8 inches wide. It's specifically built for live environments where a drop signal simply isn't an option.
So the next time you're sitting in a sports bar, marveling at a flawless 4K broadcast of a game with booming, perfectly timed audio, just remember, there is likely a tiny hidden 5-inch box just like this doing the heavy lifting.
Exactly. Quietly interleaving analog audio into a digital fiber optic light beam to keep you totally clear of that data traffic jam.
Spot on.
But this raises an important question for you to consider. If a tiny 5.8-inch box can effortlessly manage 12 gigabits per second of data over light for professionals today, how long until this exact fiber optic infrastructure becomes the mandatory baseline just to run a basic home entertainment system in your living room?